What's happening, geometry peeps? Today we have surface area and volume of spheres. Alright, spheres are awesome because we only have two formulas to deal with. The surface area of a sphere is pi r squared. Alright, pi r squared. And the volume is 4/3 pi r cubed. Pi r cubed. And the way I like to remember it is squared goes with area, cubed goes with volume. Now, the main piece of our formula is r, all right, which is our radius. And what makes a sphere so cool is the radius is the same direction, is the same distance in any direction, whether you go up, down, right, left. As long as you're going to the edge of the sphere from the center, that's always going to be the same. And that's what makes a sphere, because it's equidistant from the center. And that's why it's perfectly round. Alright, so let's just dive right in and put these formulas to use. Alright, so 4 pi r squared, 4/3 pi r cubed. Alright, let's zoom out so we can see our lines here. So, the first one, we're given a diameter of 24. Now, when they give you this whole line across there, we know it's a diameter. If you look over here, notice they only give you a half. 15 would be our radius. So, over here, I know my diameter is 24, which makes my radius 12. And that's the important piece we're using here. So surface area is 4 pi times radius squared. 4 pi times 12 squared. 12 squared is 144 times 4 is 576 pi. My units are inches squared. Alright, now for volume of a sphere, we have 4/3 pi times radius cubed. So in your calculator, you go 12 cubed times 4/3, or 4/3 times 12 cubed. And that gives you 2,304 pi. Alright, inches cubed. Now, don't be alarmed. You put 12 cubed and you notice when you multiply the fraction, your number got bigger. Well, that's because your fraction is 4/3. It's a fraction that's larger than 1, so it's actually going to increase this value. So that's correct. You didn't make a mistake there. Alright, now let's talk about a hemisphere. Now, hemispheres can be a little tricky. Think about if we were to take the surface area of this one and paint the entire sphere. We're going to spray paint it. Alright, so we would do the whole area, which was 576 pi. But think of if we were going to cut it in half. If we were to cut it in half, the bottom would still be spray painted, but think about this. This top here would be exposed, and it wouldn't be the same color as the other paint. So you have to be careful with this hemisphere. So surface area of a hemisphere, again, if we were to cut the whole thing in half, would be 2 pi r squared. If I take 4 pi r squared and divide it by 2. But we have this extra circle now that's exposed. So we have to add one more circle, which is pi r squared. So we have 2 pi r squared plus 1 pi r squared. Well, because they both have pi r squared, we can actually say the formula is 3 pi r squared. Alright, so that gets a little tricky, but we have to add this extra one, again, because if you spray paint the whole thing and then cut it open, the solid inside would still be exposed and not painted. So we have to consider that here. Alright, so if my radius is 15, my surface area is 3 pi times 15 squared. 15 squared is 225 times 3 gives me 675 pi meters squared. Alright, now think about the next problem. Think about volume. Now with surface area, we had to add, an extra circle. We had to add an extra circle. Now, is that still true with volume? Well, think about what volume's measuring. Volume's measuring the space inside of the figure. I'm actually cutting the space inside of the figure in half because I'm cutting the whole sphere in half. So the amount of space fitting inside the figure actually is just cut in half. So we don't have to compensate for that extra piece. So 4/3 pi r cubed divided by 2 is actually 2/3 pi r cubed. So if you take the formula and divide it by 2. So here my radius is 15. Alright, so we have 2/3 pi times 15 cubed, and 15 cubed times 2/3 is 2250 pi meters cubed. Alright, so again, to recap the hemisphere, for surface area we have to compensate for this. For volume we don't, because we're not changing the space inside. Alright, that's all I got.